This video covers how to calculate the depth of a box or pan for a straight die. To avoid the box or pan side from hitting the upper die holder is the goal. Using algebra and geometry, a formula can be derived to determine the deepest side height possible. There is a link in the description to all press brake content and a thread explaining how the formula was derived. The thread includes PDF drawings and a spreadsheet calculator. The goal is to know in advance what depth is possible when bending up a box or pan with a straight die. If the side height is too large for your die, bent metal will collide with the upper die holder and ruin the part. The photo shows where metal could hit the die holder. This box was made and TIG welded in a previous project. It's shown here as an example of a typical box or pan bend situation. In the previous video, we made a box or pan like this with an arbitrary 2-inch side. And there was a question raised as to how deep we can make this box with a straight die like this. So the situation that you have here looks like this, and your die comes down, bends the metal, and your die holder is up here and projects a certain amount beyond the face of the die. So there's a possible collision point right in here. So the question we want to answer is, given this die, how deep of a box can we make to avoid a collision between this side and the die holder? There's a link in the description to press brake content. It also includes a thread that does a deep dive with the algebra and geometry that mathematically calculates how to do this. There's a spreadsheet in there too, so you don't have to fiddle with the math. You can put in your die height, the width of the die, and then provide some dimensions on your die holder and whether it's chamfered or not. And the spreadsheet will spit out a safe distance here. So there's that available for those that are interested. But we can do some things that are kind of interesting mechanically. Take it off the sheet, the theoretical sheet on the press brake, and I'll show you that right now. First thing, if you have a precision V-block, 90-degree die should sit right in there, and this one's pretty good. It's a little bit wiggly, and maybe there's some dirt here, or maybe there's some dirt in here, but it's pretty close. So this is going to be 90 degrees here. So we've got that, we checked that. If we use 2 pieces of paper as a shim, a 1, 2, 3 block, and then 3 precision parallels like this, 90 thousandths welding rod, and a little spacer block, we can actually construct the geometry on the press brake, and we can verify that the theoretical calculation in fact shows up on the actual bending situation, just to check it out and make sure that the math is correct. So let's go over and do that. We'll need some tooling and machine specific dimensions for the spreadsheet. These won't be precision measurements, but accurate enough to provide a meaningful clearance distance for a box and pan depth. Measure the height of the die from its shoulder to the bottom of the bend center. Lots of ways to do this, and one simple method is shown. Feel free to be creative with the tools and parts you have on hand. The die width is also required. Note that the bend center might not be exactly in the middle. In this example, my die is off by 15 thousandths, which I did account for to help with accuracy. The projection of the upper die holder beyond the bend center is important because it influences the available metal clearance. The die holder might be chamfered, which provides additional space. That space increase will be half the chamfer face distance. It's simply half the diagonal of the square box drawn around the chamfer sides. In this case, it provides an extra 1/16 inch of clearance. I went ahead and plugged these 4 numbers into the spreadsheet, which are shown in the green cells. The spreadsheet computed the available metal clearance at 2.149 inches. So let's call that 2.150 inches for an easier number. Next is to do a mechanical construction of the geometry on the press brake to see if there is agreement between the theory and practice. Okay, we got all our goodies here. First thing, we'll put some paper shims underneath this die to give a little bit of pliability. Here's our welding rod. Put that in there. That handles the radius in the lower die and prevents these sharp corners from misregistering against this radius. So we'll bring in a precision parallel across the back. We'll set that right up against the rod. We have these two precision parallels. We'll put one on the right, one on the left. We'll let this overhang a little bit so we have an edge to support the 1, 2, 3 block. Go ahead and crank this down and put a little bit of pressure on it. So now the face of this precision parallel is projecting off the face of the die. I'm looking in there. It's registering pretty well. I can feel just a little bit of slop in there, tiny little bit, so I don't know whether the angle on the lower die is a little different than what's on the upper die. We don't know, but it's pretty close. So we'll put in a little spacer block, and then we'll put in the 1, 2, 3 block here. And so what we're looking for is, according to the spreadsheet, 2 and 150 inches. 2.150 inches is what we theoretically calculated from the bottom of your pan to where it would hit this die holder. So I've got a chamfer on this, which is an 1/8 inch face. So there's a parameter in the spreadsheet to deal with this, but it's very simple. If this is an 1/8 inch face, then what you get is an extra half of that, or a 1/16 of an inch. So if this is properly calculated, we're looking for 2 and 150. This is a 152 drill, so we put that in there, and it's pretty close. Like I said, there's a little bit of misregistration going on here, so if we take that out, we're pretty much dead nuts on right there. So the theoretical calculation for this and the actual measurement on the machine is pretty good. So that gives you an idea of how deep a pan you could bend before the side comes up and hits your die holder up here. The dimensions I have on my die is 3.836 inches by 1.090 wide, and there's a 0.340 overhang here, and then my chamfer face is 125. And remember from the previous video, my die face is offset by about 15 thousandths just because of the way this die is made, so that has to figure into the calculation. But we basically reconstructed physically the theoretical geometry that's shown in the drawing right on the machine, just as a double check to make sure that everything agrees. But you can play around with this, and I think you can see kind of where this is headed. You actually could use a setup like this in advance. Don't worry about the math, don't worry about the spreadsheet, just kind of set it up this way to give you a little bit of an idea of what your dimension is before you make a miscalculation and set up a pan that may be deeper than what your tooling will allow. So that's how it works.